All right, we know how to graph lines now. We also know how to graph absolute values. So what we're going to look at today is graphing inequalities in two variables. So the difference is that today these are inequalities. So we're not going to have an equation with an equal to. So here are the examples of what inequalities look like, linear inequalities. So you should recognize this form. So this is standard form for the equation of a line. So like where we have ax plus by is equal to c. So that is the standard form of the equation of a line. The only difference is now for inequalities, instead of having an equal sign, you have an inequality sign. So it could be a less than, could be a greater than, a less than or equal to, or a greater than or equal to. Okay, so we have to look at how to graph those. Let's start off with an equality. So notice here, this one is just an equation. This is a standard form for the equation of a line. All right, and to graph that, we can put it in slope-intercept form, or we can graph the intercepts. I'm going to try the intercepts first of all. To get the y-intercept, substitute in 0 for x. So that means the y would have to be 2. Find the x-intercept. We substitute in 0 for y. So remember, like the cover-up method, so the 3y is gone. So what times 2 will give you 6, so that would be 3. So then I have 2 points, so then I can draw the line. All right, another way to do that is to put it in slope-intercept form. So we would subtract the 2x from both sides, then divide by 3. So we get negative 2/3 x plus 2. There we have it in slope-intercept form. The y-intercept would be 2, and the slope negative 2/3, so down 2 to the right 3, and we get the same thing. So remember, that's how we graph a line. Now pay close attention here. We are going to look at graphing then the inequalities. 2x plus 3y. We're going to use this 2x plus 3y is equal to 6. We're going to remember what that graph looks like, but we're going to graph the inequalities instead. Okay, let's do this first one. 2x plus 3y is less than 6. Well, we kind of in our mind, we substitute in for the less than sign and equal to sign. So we're looking at what we do here, how we graph this guy. And that one we graphed earlier, and we said it had an x-intercept of 3, it had a y-intercept of 2. Well, that line then that goes through there is our boundary. Before we draw the line though, we have to take a close look at the inequality sign. And this says we don't want it equal to, we want it less than. So that means our line when we draw it is going to be a dashed curve, a dashed line. And then we have to shade one of the regions, either below the line or above the line. So what we're going to do is take a test point. So let's take the point 0, 0. If I plug 0, 0 into this inequality, 2 times 0 is 0, 3 times 0 is 0, and I want to know, is 0 less than 6? And yes, it is. That's a true statement. So that means that we shade on the same side that point was on. So we're shading here. Okay, let's take a look at the graph. 2x plus 3y is greater than 6. So remember, we think to get the border then, the boundary line, we think of the equation 2x plus 3y is equal to 6. Once again, that's the graph that goes through the y at 2 and the x-axis at 3. This one has greater than, so that means it can't equal the points on the line, so that's why we do the dashed line again. And this time, let's say if we pick the 0, 0, this point right here, and we plug it in, we get 0 plus 0 is greater than 6. And 0 is not greater than 6, so that's a false statement. So that means we do not want to shade on the side where that point was at. So the 0, 0 was on the other side, so I'm going to shade this side. Well, that makes sense. The left one, it's less than, so the other one is greater than, it's going to be above. This next one, subtle little difference here. The only difference is up here I had a less than, here I have a less than or equal to. So when I go to draw the boundary line, which is still the same one, y-intercept 2, x-intercept 3, is it can equal the points on the line now. So instead of drawing the line dashed, oh, it looks like it was dashed, I draw it solid. And then we want less than, so we know from above that we shade this sign. And then this last one then, you can probably guess what it's going to look like. Draw the boundary line. It's greater than or equal to, so because of this, we make it a solid line again, and we want it greater than, so it's like the one above, we shade there. Okay, let's try this one. We have the inequality y is greater than negative 2x. So remember, step 1 is to come up with the boundary line. So we need to find the boundary. And so to get the boundary, we change that inequality sign to an equal sign. And think of what that would look like. Y is equal to a negative 2x, so that's in slope-intercept form. That doesn't have a plus b at the end, so that means the y-intercept is 0. And we have a slope of negative 2, which is negative 2 over 1. So we go down 2 to the right 1. Down 2 to the right 1, or up 2 to the left 1. This is our boundary line. So then step 2 is to decide, do we want a dashed line? Do we draw it dashed, or do we draw it solid? Well, that depends on this sign here. This just says greater than. So greater than says it cannot equal the points on the line. So that tells us then it's dashed. Okay, so then I go back, I sketch in that line with a dashed line. And then the last step, the third step, is to decide where the shading goes. Do we shade above or below? So we do a test point. Well, I can't use 0, 0 because it goes right through the boundary. Let's take the point 3, 3. So we go back to the inequality. Both the x and the y are 3. So we substitute in. So we say is 3 greater than negative 2 times 3. We get 3 greater than negative 6. And yes, it is. That's a true statement. So we shade on the same side that that point was at. So the point 3, 3 is up here. So we want to shade above the line then. We have to shade and include that point because it was a true statement. Let's take a look at this one. X plus 3y is less than 9. This one is in standard form. So we look to graph the boundary first. Okay, so the boundary first. I'm going to change it to slope-intercept form. So let's subtract the x, and I'm going to change it to an equal sign. So it'll be negative x plus 9. And then we want to divide by 3. So we get negative 1/3 x plus 3. That tells us our y-intercept is 3. Our slope negative 1/3, so down 1 to the right 3. Down 1 to the right 3. Or up 1 to the left 3. Okay. Second part, do we want solid or dashed? So we take a look at the inequality sign. It says just less than, so it cannot equal those points. So therefore it's dashed. Okay. We'll put the arrows on it. And then the last step is where do we shade? Okay, let's take the point 0, 0. If we plug it in, 0 for both the x and the y, we get 0 plus 0 less than 9. Is 0 less than 9? Why, yes it is. That's a true statement. So we want to shade on this side that point falls in. How about this one? X is greater than or equal to negative 2. Okay. This one, remember, is a special type of line, so we only see the one variable there. So we're doing the boundary first of all, so we're looking for the points where x is equal to 2, negative 2. Well, negative 2, 0, there's a point where x is a negative 2. Negative 2, 3, there's another point. Negative 2, negative 1, there's another one. So if I looked at all of the points where the x is negative 2, we'd have a vertical line. All right, so I want to look at the vertical line. We have to decide, is it dashed or solid? Well, it can equal those points on that line, so it's going to be solid. And then we have to decide where to shade. Okay, let's take this point here, negative 4, negative 1. So when we plug it in, well, the negative 4, negative 1 doesn't have a place to put the y value. It says just take the x value. So our x is negative 4. Is negative 4 greater than or equal to negative 2? No, it is not. That's a false statement. So our shading then is on the opposite side of the side where that point lies. Okay, so there would be the graph of that inequality. Let's take a look at a simple kind of application of this. So we have a brownie recipe that uses 2 eggs for every batch, and a cake recipe that uses 3 eggs. And we want to know how many of each can we make if we only have a dozen eggs altogether. Okay, well, let's let the brownie, the number of brownie recipes, I don't know how why are we not getting rid of that? Let's say we want the number of brownie recipes, that's going to be our x, and the number of cake recipes that we make is going to be the y. All right, for every brownie recipe, so for every x recipe that we make, we need 2 eggs. So 2 times x. And we need 3 eggs for every cake that we make. And we only have a dozen eggs altogether, so we can use all dozen, or we can use less than that. So here's the inequality that we're looking at. So let's go ahead and graph that. I'm going to graph it by finding the intercepts. So if I put in 0 for x, the y would have to be 4. if I put in 0 for y, remember we're treating it as an equal to sign. To get the boundary, it has to be equal to. If I put in a 0 for y, then what x value times 2 will give us 12? Well, that would be 6. So the x-intercept is 6. I'm ready to draw my line. I want it less than or equal to. So it's a solid line. And the shading then, let's take the point 0, 0. If we plug it in, 0 times x plus 3 times 0 is 0. Is 0 less than or equal to 12? Yes, it is. So we want to shade on this side. Now, because we're looking at recipes, we are not going to make a negative number of recipes. That doesn't make sense. So really, it's only this region in here that really makes sense. Maybe I'll change it to red. So anything in here or on the boundaries would be a plausible solution, because we can't make a negative number. So anything in there. So for example, the point 1, 1. So that means we can make one recipe, one brownie recipe and one cake recipe, and yes, that would only take 5 eggs. That we could do. We could go over here. We could make 6 recipes of brownies and none of the cake. And 2 times 6 is 12, and yes, 12 is less than or equal to. So all of these points in here are possible solutions. Okay? All of those would work. Okay. We have one more. Since we just talked about absolute values, let's see if we can do an absolute value. Notice you have the absolute value bars, and we have an inequality. So this is going to include shading. So when you learn to do the absolute value, Ms. Preston talked about the parent graph, and the parent graph of an absolute value has the vertex at the origin. It opens up with a slope of 1 and -1, and then we draw that in. Well, we're taking this curve, we are shifting it. Look at the inside. The inside there is -3, so we're shifting it to the right 3, and then a +2 at the end, and then up 2. And that negative on the outside of it turns it upside down, so we're not changing the shape of it. So we're looking at these points right here. Would be points on the boundary. Okay, then I have to decide, do I want it dashed or solid? Well, it's less than or equal to, so we want it solid. It's going to look like this. And then we have to look to see where we shade. Let's take the point 3, 0 to plug in. So 0 is going in for the y. Is 0 less than or equal to the opposite of the absolute value of 3 minus 3 plus 2? 3 minus 3 is 0. Absolute value is 0. The opposite is 0 plus 2. So we get, is 0 less than or equal to 2? Yes, it is. So we want to shade where that point lies. So we're shading inside the V there. And it includes all the points on there also. Okay, so I'm using a new program here, so I hope that that worked out okay for you. So maybe you heard some funny noises and sometimes some different things came up, but I'm trying a new program, so thanks so much for bearing with me, and good luck with graphing inequalities.